Hello.
Hey, Yuri, how's it going? You hear me okay? Yuri?
Hear me?
Talk again?
Can you hear me?
Yes, can you hear me okay?
Yeah.
Okay, good, good. How's it going?
All right.
Yeah.
Yeah. Hold on. I need to switch this.
What's that?
Is this better? Like, did sound switch?
Sounds great.
Okay.
Yeah, yeah, very good.
Yeah, I haven't been able to do any NLP work this week. I'm like, it's like a deviation on top of deviation.
You were doing crop similarity before, I think, or sort of moving in that direction, right?
Yeah. So I'm working on that. Yeah, time series similarity.
Time series similarity, yep. You read anything or learned anything?
No, nothing interesting. I was like coding and running, you know. Yeah, so we did this, like somebody else actually did this work. I never worked on it till 2 weeks ago. And it sat there for a year. And now all of a sudden we need to like use it. So it's so crazy.
And what is that? What kind of a project is that?
So that's the similarity. Right? We basically take all the agriculture related time series and find districts in the world that are similar. So yeah, there's like not a lot of new development on this project, but it's just debugging and running it. And
What do your customers use that for?
so classically there are two ideas like why it can be used. One is you have like you want to expand into some area, and you want to see what will grow well there. So you'll take that district and see what area in the world is similar, and then what's growing well there. And then you can add, this is just what should grow well just because soil is the same, temperature profile and moisture profile is the same. And then you can add to it like how much it would cost, what would be like water consumption. You can like do all things on top of that. So that's one thing, is like you have a land and you want to know what to grow there. The other thing, you're growing some crop and you want to know where else can you grow it. So then you run similarity and you say, well, what district is similar and can I grow it there?
Is the actual time series similarity of crops or of land? It's got to be
Oh
crop.
no, of land, yeah.
Really? And it's satellite data only?
Satellite. I think it's most of it is satellite, like one way or the other. At least like all the recent data is satellite based. Like they had temperature, precipitation from before satellites, but now satellites give you much better coverage. So
Literally on satellite images, you can not even crop specific.
no, I guess no. Some data is database, like a soil type that's just known, that's been like measured. Yeah,
I get it. So it's a multimodal problem, or it's all you're putting into the same vector space, or is it more of a tabular data?
So we'll look at it. We'll look. It's actually on our Git, like open GitHub. We'll look at it as a data distribution. So we don't look at it as time series, but like we look at the data. We average data for every week of the year. So you can think about it as 52 points in, let's say, three-dimensional space. So it's a distribution. You can also think about it as like, actually connected distribution, because you move from point to point every week. But it turns out like we were trying to solve it before as a time series, and just looking at it as just distribution of values, that's good enough. Because
How do you integrate the data into that when you have satellite data and then you have structured data?
oh no, satellite data just that gives you temperature and precipitation.
Oh, it's not image. I was assuming.
No. It's already yeah, somebody already like calculated that, and what we do is we actually like we don't deal with low high resolution data. We're already like at the district level, so we at like much larger aggregation.
Hey guys, I was just questioning Yuri on the time series crop similarity time series stuff. So thanks for that, Yuri. That's interesting. The uses too. I don't have too much to share myself. I have started using Fast API as opposed to Flask. So I'm rewriting a server that I use to run a bunch of my proof of concepts that is mainly centered around a word to vec model. And I've already created a ton of technical debt, just me as the one guy on my engineering team. And so I'm circling back around because I need to support more use cases and proof of concepts. And so I'm rewriting that. And I said, screw it, I'll try Fast API. And I'm happy. Fast API is great. If you're creating a RESTful API, there's no reason not to use it if you're using Python, I would say. So that's about my big learning this week. I did have a couple of questions about some things that came up this week, but I'd rather open it up in case anyone has a burning question or wants to share something with the group. So anyone have anything that they want to throw out there to start with?
Okay, so this is more administrative question. So I don't know if you saw that Sam is doing this survey on what can be improved.
Sure, of course.
And I wrote my favorite pet peeve is that this Slack is free, so all the links go away after some time. And I ask, so maybe TWIML can pay for Slack. I don't know how expensive it is.
Yeah, remember they were talking about moving to Discord? Was the Discord not the other thing? The fast, like Fast AI uses. What is that?
Yeah, I always confuse those two.
I don't want to move off of Slack.
Yeah.
Yeah, I don't know. But you submitted that as your
as my like improvement suggestion. But yeah, that's because I started copying links at some point, but I don't do it consistently. But,
yeah. I don't know. Does anyone have any idea how much that is? Right. If it's not a lot, there's maybe other solutions for that money. Okay. Anything else?
No.
Okay. All right. Anyone else?
I did something, but I'm not sure if it sounded like a good idea at the time, but I'm not sure if it is still thinking about it. So so we were talking about search, some medical search, right? So if you do a search for, say, GERD, right? A GERD is gastroesophageal reflux disease. So, you feel acidic things coming up, right? And you get heartburn and stuff. So if you search for GERD, one of the results that we were showing is coughing, right? Whose side effect could be GERD, right? So apparently that is not what we want, right, in our search results, according to our domain experts. So they came up with this idea that, we should try to, expose the topics of each, each of these search results and store them in a separate thing. So whenever we find, so by the way, we have a way to figure out if a search is, topic specific or topic generic, right? So we have some rules there. So once we do that, we want to match up against or give preference to documents which are, so if the query is topic specific, we want to give preference to documents that are topic specific. And whereas if a query is topic generic, we want to give preference to documents that are topic generic. So kind of follow the query, right? So, and there was this insight that at least for journals, if you just, use the concepts that are available in the abstract, then, you tend to get what you want for journals. However, there is, at least they didn't have a way of, when they were thinking, that they didn't have a way of doing this for books and other publications, right? So my bright idea was that since we know the document text and the abstract of all the journals, we could train or fine-tune a summarizer model, right, to take in one of those texts and emit something like the abstract, right? And we then, once we take the fine-tune model, we then apply it to other document types, right? So, like book, chapters, and guidelines and whatnot. And then on the summary, we then, use our concept mapping technology to extract concepts, and there you have it. We are done, right? So this was what I proposed yesterday, but then I started thinking about what our summarization technology really is, right? So typically, basically, the idea of summarization is that, you find concepts or you find keywords or what have you, right? Or some sort of similarity. So the stuff in the summary corresponds the closest to the overall stuff in the article, right? It is the most similar. So it, it takes those sentences and kind of, puts them under almost like a magnifying glass, so you can, see the good stuff and not so much of the bad stuff, right? So I'm wondering if, we actually need summarization. If we cannot actually, while we are doing this entity extraction and concept mapping, if we actually cannot just look at the frequency distribution and infer the top concepts from there, right? So that's been what I've been thinking.
So
anyway.
you're talking about freeform top concepts, not from one of your controlled vocabulary.
No, controlled vocabulary. Everything is controlled vocabulary for us.
So do you have a single controlled vocabulary, like one thesaurus or whatever?
Yeah, it's a single control vocabulary, which is a combination of many control vocabulary. So you basically take SNOMED, UMLS, and all these other things. And then you, there is a process which is called, they basically align, that's what it's called. Entity alignment is what it's, right? So if you have, say, a SNOMED article about a broken arm, and you have UMLS concept about a broken arm, you would kind of merge them into the same concept, right? So, yeah.
So, but what you, for search purposes, what you want is full article aboutness. Okay, is this article or chapter or whatever about this entity or about this topic, right?
Yes, but it depends on the query. If we decide that the query is like, so
if it's topical, if someone searches for GERD, right? A GERD, that's topical for sure, right? And that's a topical that matches. It's like what you're doing is like entity or whatever linking into your thesaurus on the fly at search time. And that one has a high probability, obviously, that links to a very specific topic in your semantics, right? In your thesaurus. And then what you do, so are you talking about, like, so if you do full, I know there's other aspects of this, but if you're doing sort of full text aboutness, right? Typically the way we think about, at least in the past, is you do a supervised algorithm, right? It's a classification problem. and you take your vocabulary, you have samples, and you train it, right? Now, not all of them are going to have enough examples, but a lot of them will. And then you have a model, and then you can predict with that model, right? And you could actually in advance assign your topics to the content, okay, from that thesaurus. This is straightforward, right?
Right.
It's not easy to do, but the idea is straightforward. And then when at search time, if it links in, you just pull all the documents back that are already pre-classified to that topic.
Right.
Threshold, right? So why aren't you thinking about it like that?
We did actually. So we thought about using, doing topic modeling and, doing repeated seeds, repeated values of K, right? And choosing one that kind of makes sense once it's done. And then using the topic vector to drive, topicality, right?
So what I was talking about was not topic modeling at all. It was a supervised approach.
Right, but you need inputs
To match the query.
No. So you need inputs to to match the query as well. But instead of using like a complete vector, right, like a vector that you pick up from a language model, we are going one step further and we are creating a topic vector, right? So maybe like, you have say 100, 150 odd topics, right? And then you basically create topic vectors. And the idea is that the topics you create correspond closely with reality, right? Or so basically every time you do a topic modeling, you inspect the output and then you choose the one model that gives you topic vectors that are closest to reality.
A topic vector is just a embedding vector for that.
It is treated as an embedding vector, yes. So, but
is it embedding vector as for like words that basically is combined into the topic, or like it's more?
So when we do the topic vector, we would we would basically run concept mapping on it, and so we would keep the phrases that are so essentially how so a topic model is basically two probability distributions, right? It's the probability of the topic given the tag topic tag, sorry. So it's a probability of the document given the topic, and it's the probability, the second one is the probability of the topic given the tag, right? So in our case, the tags would be concepts, right? So, but my point is that this topic vector, the document given the topic, this would actually mean something, right? Because it says that here is a vector and here are each of these slots. We don't know what the topics are, but they are really good groupings of what we think our topic should be, right? So that's what we were experimenting with, and using that to build a classifier that will predict generic versus specific. It didn't actually, nobody liked the idea, basically, I think. We didn't try it, but yeah. So this was a new idea I threw out, but now I don't like it. So anyways.
the whole game is to identify queries that are linked, right? It's like link entity.
Yeah, well, I know how to identify queries that are topical.
Right, and then, but what I'm saying is the whole idea is then to prejudice the results towards that.
Exactly, right.
Towards the pre-processed knowledge of those documents. So again, let me make it really simple. If all of your content has been automatically in the background classified or manually, which you're not doing, we do that. So to those topics, then you already know that we have 2,000 documents that are highly about this topic, and it's just you don't have to use all the vectors and everything directly.
That is my point. I mean, I'm thinking that maybe all this stuff that I'm thinking of, this we can just do it with frequency, but it's frequency. I don't know.
But what I was saying wasn't what do you mean? What I was saying wasn't frequency. I mean, it's a simple thing. A document or an abstract or whatever classified as about GERD, like majorly about GERD.
Right.
It really covers that, or significantly, which is a little less, or whatever. Use numbers 0 through, use 0 through 1. And you just it's a database query. I mean, it's a field.
I see. Okay, I see.
Fielded query. Okay. We already know this document's about GERD.
Right.
Just bring back the top, 10 documents about GERD, and then maybe or take those 1,000 documents about GERD, right? And then you re-rank them because you know the search is GERD, and it has some other words in there too, right, along with GERD. So you take your 10,000, your 1,000 documents that are explicitly and wholly about GERD, and then you re-rank them based on the other words they're using with the word.
It's something like RM3. Okay, yeah, that makes sense.
It's a basic. I mean, it's a more straightforward way to do it.
Right. Yeah. So anyway, so it was kind of an exercise in nothing, right? We came up with 2 ideas, but then now I'm beginning to think that it's really, we don't have to go that fancy. But anyway.
Yeah, we all do that as practitioners.
Right. Yeah.
And engineers. Okay, cool. Anybody else? Mayank, you have anything? Are you able to talk? You have a good voice connection, or? Can't hear you if you're talking. Oh. Still don't hear you. Looks like your mute is off, which is good. I have a mic issue. Okay, at the moment. Okay, well, let us know. Just break in when you fix your mic issue and so forth. So, in the meantime, I did have some. Does anyone want to bring anything else up? Because I have a couple of topics we could discuss briefly, mainly for my education. Okay, so there's the. Oh, I know. I came across this. I don't know why. I don't remember anymore. Machine teaching, like this. It's been popularized recently by Microsoft, stuff Microsoft's focusing on. Does anyone have any knowledge of the whole machine teaching thing, and have they used it? Because what I try to do is I was thinking, well, machine teaching, I read about it a little bit, then I'm like, oh, well, maybe there's some, library I can use to play with it to get an intuitive understanding of the affordances of machine teaching. Does anybody have any, okay, Mike, you go ahead. If you have anything you want to just say hello or bring up or anything. You have anything? Can you, I don't hear you still.
Can you hear me now?
Yeah, there you go. Yeah, I see there's 2 of you.
Okay, so my name is Mani. I think his name is Maya.
Manny. Oh, Manny.
Yeah.
Manny. Okay, cool. Sorry about that.
Yeah, I'm actually working on mostly weekly supervised. So we don't have like a lot of training data. So so most of the time I use Snorkel to create labeling functions in order to actually enhance my training data. I wonder, it starts with like keyword-based heuristics, which the domain experts provide, and I typically try to convert the into labeling functions. So I wonder what are all the other interesting ways that I could try. So I have heard using zero-shot classification is one other way to actually try. I wonder if there are any other ways to actually to try.
Hey, Suji, I just post the link to that paper, but I think Suji just posted a link that might be relevant, right?
That's more augmentation.
Oh,
you can definitely get ideas from that. One aspect one way we have done it. It's not well, it's probably also possible with Snorkel. Basically doing active learning kind of deals, right? Mm-hmm. Where you train a model partially with whatever data you have, and then you make it run over the whole corpus, or using active models, you can make it run over, only show you results for which it is unsure, right? And then you have humans label that and shove that back into the training pipeline, right? And over time, we have tried this. We have actually we went from I think 1,000 to 6,000 training data, and as we got more and more training data, we actually went I think from 65 to over 92. right? Just 92 point something. This was for like a classification kind of thing. So
that is so. Is it actually like if you're, what if the model is actually like performing lower? I mean, the whole idea is to actually like provide a varied set of
yes,
samples,
yes.
right?
Mhm.
So I actually like adopted a similar approach to actually find noisy labels to using the basically like try to identify based on the confidence score, like if it is highly confident but the labels are like saying something else, I try to actually like identify noisy labels, but still like certain times it's the model is really unsure in terms of, so what happens when the question that I'm asking is, when we are using the already trained model to actually like increase the training data, do you use how confident the model is as
Yes.
well? Or?
Yes. So there are methods. So I don't remember them. Look at modal, MODAL, right? So
Okay.
they have different.
I just posted that sucker.
Okay. All right.
I see. Okay.
So they have different policies by which they can make this determination. One of the ways I remember is basically how close it is to the So if you think of classification as like a SVM kind of deal where you have a hyperplane separating the negatives and the positives, right? How close it is to the boundary, right? You can measure that, and using that. So the idea is that you don't want to waste people's time, human time, in giving or asking you to relabel examples which are far away from the boundary, because the model already knows what it is.
Right. Exactly.
Right? It's only the ones that are close which gives you the maximum bang for the buck, right? So you let the human work, do the high value work basically, and So
okay, Manny, let me understand a second. So you have some sort of classification problem. You've built a model. You see certain areas and certain labels where it's unsure, and you want to shore up those specific areas of the model. Is that correct?
Right.
Okay, so you want to improve those. Of course, tools like Prodigy, which is Spacey's tool, are built exactly for that and for active learning, using active learning. But they're paid tools, right? That's a paid tool. But I see.
Yeah, so I can able to actually correct certain things, but it's really like a domain expertise is needed in order to actually like.
What is the classification problem? Can you give us a teeny bit of context?
It's basically like support case routing on the technical areas. So, whether it belongs to a kernel or it's a networking problem. So it's very hard to actually like, without knowing the technical domain, it's very hard to actually say which.
And within those areas, how many areas do you have roughly? Like 10 or 1,000?
No, it's around like 40 to 50.
Oh, okay. That's a nice.
Do you have the resolution for your, so if you're looking at tickets, right? You would have the resolution, what happened, how did they solve it?
Correct.
Give you some information.
Yes, that's correct. That is correct. Sometimes it's, it's not, it's more around like during inference time, which particular domain experts or like specialty group can really solve the case. Yes, you are right, Steve. The resolution is actually like linked with the case. So, but
it's hard to classify the resolution, I guess.
But during the inference time, we will not have the resolution. So, yeah, that's why I did not. I never used. So whatever that is available at the inference time, that's the those are the features that I'm using.
It would be nice in the workflow if we're able to say this is the wrong area, like you shunted this wrong. That would be some feedback. What's the main algorithm you're using? Or the main
It's a text classification problem. So I still use ULM-FIT. I haven't switched to BERT yet.
Oh, yeah, well, I think my guess is that sometimes ULM-FIT does better. Anyway.
Yeah, I've never felt the need yet, to switch to BERT. So it's mostly optimizing the data. I try to actually let's see how much I'm getting for just by optimizing the data before switching the architecture. So it's working well. So
how many samples roughly do you have per category?
I use around like 100,000 samples for the training data.
Oh, dude, you got only 50 topics.
It's mostly like the data itself is imbalanced because like certain specialty actually get very low number of samples. So, but certain specialty actually gets really high. So it's highly imbalanced data set.
Well, how do you deal with the imbalance? Are you using weighting? Are you upsampling, downsampling? What are you doing?
At the moment, I'm not doing any upsampling or downsampling at the moment. Actually, like I still haven't actually like tackled the. I tried with weighted. Actually, like I'm not actually like dealing with the imbalance. I'm mostly restricting the. I'm still dealing. I mean, I'm still actually like. I'm not dealing with the imbalance problem yet. So it's mostly right now what I was actually like facing was it's the incorrect labels. That's the part which I was actually dealing with. I mostly use label smoothing, but I'm not actually like I haven't corrected the imbalance problem.
What's label smoothing?
So label smoothing is a technique that I use it as part of the loss function, label smoothing cross entropy. So it's part of the FastAI itself. So it's to actually like not to it's basically to actually like there are certain percentage of incorrect labels present in my data set. It's to minimize those I'm not actually like able to correct those labels, so I'm just using label smoothing technique.
So some kind of regularization, I guess, right?
It's probably the regularization of the probability that you get out of the softmax or whatever you get out of the cross entropy. So it's like confidence. You remember that stuff, Suji, you brought up about confidence?
Yeah, I think Money also said the same thing, right? About,
yeah.
Okay, well, that's cool. Label smoothing, that's a new one. And I have no idea. I mean, like when people talk about imbalance, a lot of times you're talking about like toxic versus non-toxic. So the imbalance is just ridiculous. And in that case, fixing the imbalance is everything. But in your case, I just don't know how much fixing imbalance is like, will they change a % of accuracy or, I just don't know. You know what I mean? So it's hard to say how maybe someone else has a better feeling for that.
Yeah, that is one thing that I wanted to fix, but I really.
And you're using a threshold, right? When you say you're getting bad classifications, bad labels, you're using a threshold below which you don't give it that label, right? Oh, because I know what you're doing. So what you have, so another way to attack this, and I always struggle with this, is basically probably the probability you're getting back. Do they all add up to 1, right? So you have 50, and the vector that's returned has 50 dimensions, right? 50 columns, 50 values, and they all add up to 1. Is that correct?
Yeah, I'm using softmax, right? So it should all add up to 1. So, yes.
So I've asked a couple times, but to me, I think that scikit-learn does this where you do 1 against all or that kind of thing. So you make it a 50 binary classifiers. You don't have to. I'm not saying to train 50 different binary classifiers, but that's sort of what they do with the scikit-learn stuff. Name of the part of it, but basically this is the point. To me, ideally for this kind of classification, what you really want is you want an independent judgment. Well, I mean, joint probability is fine, but you want a 0 to 1 probability for each topic. Okay. So first of all, that's like multi-label classification, right?
Right, yeah.
So, but by going 0 to 1 and having them all add up to 1, you're forcing an answer, and you have no way of judging whether that answer is right or wrong. But if each individual dimension, if each category you get a 0 to 1, and you set your threshold at like 0.7 or something, right? You can even do it specific to the category. You may end up with no results, right? The signal's just not strong enough, and that could be better. You could arbitrage those or whatever. That could be better than sending a bad result. Okay, and you understand, like this is it's sort of a little bit of a different approach. It's a multi-label approach, right? Because you're forcing it to give an answer, even when there's no really good answer. Maybe like I'm not confident about all 50 of these.
I see what you're saying. So basically, like, okay, if it is just saying like unknown, the model to say I don't know about which particular label would fall under.
Yeah, and you could think of it as 50 binary classifiers.
I have like, this is more of a multi-class classification problem, like to identify which specialty a support case would fall under. So I have another problem or another project which I just completed, which is okay, what are all the different types of problems that are faced by our users? So, basically treat it as like a multi-label problem, because and see how many number of support requests fall under this, like using this by adding tags to these incoming cases, can be able to identify what are all the, the top problems that are faced by the users. So in that, actually, like really, I struggle with the tags. So that's when I used Snorkel. So so in addition to the tags, like, Snorkel would also allow you to actually say like abstain from, basically do not add any label. So I added that as part of my training set as well, so that like the model can learn to say, I don't know anything about this particular tag. So that, so that's what I updated the data set to actually like say that, rather than, it's a multi,
that makes sense. Yeah, I did. I mean, so to Darren's point, though, there is like I was reading somewhere, and he says, this is like tips to improve your classification kind of thing. So he says, like, if you try to convert everything to binary classifiers, because it's easier to work with, or models find it easier to say yes or no versus saying 1 out of 6 things or 1 out of 50 things. And then try to do, post-process the results from that. So in that sense, I guess, you could have these 50 classifiers, and then each of them saying something, and then you could kind of create a vector saying that, this is all my answers, and here is my, degree of confidence. Because if, so for example, if you have 10, right, all of them are saying 0.9, 0.9, and one of them is saying 0.11, it really doesn't mean anything, right? So, so they're equally unsure.
It's a classical logical fallacy, as from a human point of view. Hey, which one do you like, killing babies or killing kittens? Or
Right.
I don't like either.
Right.
Then you send it to a human being to make the decision, or the other department.
I thought this is how the Snorkel's label model would work. It would actually say whether it would fall under any of the.
I think the label model that it works with is each of those labels that you give, it emits like a probability saying that, this is how confident I am. And those confidences are basically applied back to reweight its decisions. So if I'm, like 10% confident, and I say I'm sure of my answer, right? Or if I say this is a 1, then I get 0.1, right? Whereas my neighbor who says I'm 50%, or you know that he's 50% good at everything he does, then, and he says 1, then he gets 0.5, right? So it's like, I thought that was the way to do it.
Isn't Snorkel just giving you probability for your training set? Adding something to that top training set?
Yes, yeah, but it weighs, so it's like a 2-step process, right? So you create your labels and you apply your labels, and that input is fed into they call it something, probabilistic classifier or something. So that basically emits, the generative model, sorry. So that emits all the probabilities. So it doesn't emit like a 1 or 0 in case of a binary classification. It basically emits like a vector of probabilities. And then you feed that into a discriminative classifier, which basically emits 1 or 0, again, in case of binary. So, so I think that the weighting is done though by the generative model. It basically weights based on how many times your signal has agreed with all the other signals or disagreed. So it uses that to weight how good you are.
Manny, you're using the Snorkel model to build your training sets, or you're using it to do your prediction?
To build my training set.
Okay. How many?
Sorry.
Are you talking about?
Sorry, say it again.
How many problems? User problems?
So it depends on the particular product. So, on a given period, yeah, it's around like, for a given product, it's around like 15 to 17. And yeah, it's a not lot. So this is one thing that also I was thinking about. Right now, we are just, so you have like different products, and within a product, you get like different types of problems. So it's more similar. I feel like it's more of a hierarchical classification, but I don't have any experience with that. Right now, I'm just treating everything as flat. So I don't know anything about hierarchical classification.
So you're talking about combining all the problems across all the products into sort of like a problem taxonomy. Is that what you mean by hierarchy? Or are you talking about within a specific product, the 15 to 17?
So when I say what I mean by hierarchy is right now we have a classifier that identifies which particular specialty it would come into. And then followed by that, within that specialty, what are all the different categories of problems? So, so you have like 2 different classifiers, right? And if the first classifier makes a mistake, the second classifier have no use, right? So, so there is an indirect dependency, but they are like completely 2 different projects.
And how does that relate to problems?
What do you mean by that?
Well, so it was a problem. You said specialty, and within the specialties are the problems.
Yeah. So you see, like, for example, like you have like a particular product, and within a product you get different varieties of types of, this is very specific to kernel, this is very specific to networking, but a different product have different components associated or different types of problems coming into it. So that's what I meant by hierarchy. There is a type of taxonomy with which our classifier should work. So yeah.
The simplest way I've ever dealt with classification with taxonomies is I just assume up all the children. So like if you have 100 documents for this type of problem, 100 examples, but this kernel under this product, this particular problem. I mean, there's like, you've got like 10 children under this particular problem, and each one of those under, you just, you train each one individually, and the children have fewer training sets, but then the parent has all of the training sets from all the children. That's one way, simple way. Just use the taxonomy to assume up the training sets from the children. Possible.
Right, but you have like how many classifiers? You will still have like individual classifiers, right?
Yeah, so it's still just a multi-label classification problem, and as far as the algorithm knows, it's just a bunch of topics. Doesn't know about the hierarchy.
Right. That's how I'm treating it currently as well.
Yeah.
Not complicating it too much.
But the children aren't dependent on the parent, and what I was saying. Oh, I don't know enough about what you mean by hierarchy. But.
Well, one I can bring back from CNET, right? So let's say televisions, right? Televisions is like, it's easy to distinguish cell phones from televisions, right? But within televisions, you can have different, flat screen, or at that time, the one with the tube in the back, right? Cathode ray tube, right? And there was this hybrid thing in the middle, right? So those could be like sub-classifications of television. Whereas with phones, right, cell phones, you could have the flip phone. Again, I'm dating myself, and then you could have the flat one that everyone thinks of as a cell phone, right? Or you could have those, big fat monsters, right? The Motorola type of things, right? So I think I get the example. Basically, it's the same thing with tickets, right? Incoming tickets. Like you might come in and talk about something at a high level, but then you would, depending on what your specific problem was, you would go to the different classifiers in this case, but humans, or human tech experts.
Right, that's much better analogy. Yeah.
Yeah, but I could see with each ticket, you want to know product and problem as well as the general tech area for shunting, right?
Yeah.
All right, well, I had a couple quick questions. Was there anything else, Manny?
No, that's all. I think I got more than enough.
Yeah, this is actually quite interesting, the fact that you're using Snorkel. One other thing you could try, I mean, this is, okay, actually, yeah, so instead of label functions, this is an experiment I tried. I use different language models, right, to spit out the embeddings. And so I was trying to be lazy, or I was trying to see how much I could get away with, basically, right? So instead of spending time trying to develop label functions, I basically said, let me try using 8 different kinds of language models and use the outputs. You basically pass the document through it and use the outputs as my labels, right? So,
but what would be your output?
I don't remember actually. Okay, if I will look it up and tell you. Okay.
Okay. Yeah, because right now that's I it's just very basic keyword based heuristics, right. We are
yeah, and that was like no effort kind of thing. Basically, I'm just using computation, and I got a decent result. I think not very high though. It's unsupervised, totally unsupervised in this case, right? I'm not expanding any effort at all. But I did have some kind of test set at some point. I have to look up the Confluence report I wrote from that. But basically, I got a pretty high score, with no work, right? I mean, no human work almost. So yeah, I'll send it to you on Slack or something. I'll give you that information.
Yeah, sure.
I don't know, Manny, we do like to share code on here. We don't do it as often now as we used to, but if you're at all interested in any way, it's obviously super informal, sharing your screen and showing us how you use Snorkel, I would be interested in seeing that.
Yeah. Let's.
Well, without preparing anything, I mean, not now. We could do it the next meeting if you want, but if you want to do it now, it's fine. But I don't want you to spend time preparing anything, but just you
To
could.
show how I am doing using Snorkel. Yeah, absolutely.
Yeah, because I'm still a little confused about Snorkel. I tried using it a long time ago, about 2 years ago, with a group unsuccessfully. And it's evolved so much since then that I have a hard time getting the full context when we bring up Snorkel. So that would be really interesting for me.
Yeah, I just followed that spam tutorial that they had in the site and just converted into our
Well, that would be interesting. So, I mean, if you're willing,
yeah, okay,
like in the
Yeah.
next call, that'd be great. I mean,
yeah, I'll share my screen and yeah, just we'll talk about it. Yeah,
yeah,
sure.
that would be cool. Okay, I had a couple quick questions. Maybe no one will have anything to say about them, so they'll be quick. But again, I was talking about machine teaching. Does anybody know about that whole thing that Microsoft's pushing? It's not their thing, but they're trying to make it their point of view. Okay. Then there's also the topical segmentation stuff, the conversational segmentation post we had in Slack, and about the guy that was doing the trying to topically segment a discussion or translated voice discussions. And I did see, I started reading about it a little bit, Sujin. I did see the paper you did, and it was specifically trying to solve asynchronous, like sort of take it, like there's monologue, there's dialogue, and then there's asynchronous conversation.
Yes.
And that was interesting aspect. But I try to do, like I always do, like a broken record. I try to find a library that would allow me to do any kind of segmentation on any type of conversation. I didn't care which kind. I really couldn't find any. But remember when we were doing the modern slavery stuff early on? It was interesting because they were trying to find in these statements that are required for each corporation, talking about the slavery, a supply chain, in their supply chain. You have these documents, and we were just breaking them up into sentences and then classifying those sentences as what types of statements they were making, right? And about wages or about supply chain or any of that kind of stuff. And so I was thinking this is a much more natural way to do that, is to topically segment your document. That might be 2 paragraphs, it could be 2 sentences, that kind of thing. It's probably more contiguous than in the asynchronous case. So probably synchronous would work. But I couldn't really find anything. I found one that sort of used Word to Vec with a window, but it wasn't very effective. Has anybody had any experience with doing that sort of conversational topical segmentation in a successful way? Ideas about that on a document? Because you can see how useful it'd be for NLP in general, right?
Right. Yeah.
Yeah. I mean, have you ever thought about that approach?
Yeah, that's a good. No, I hadn't actually thought about it, but that's a good idea. Yeah.
For you too, right? Because all the severe science stuff or all the medical stuff, the long discussion, right? And
right. Yeah.
to segment it into topical areas, you can actually then maybe even break up those areas into separate documents and almost have a dynamic knowledge.
Yes. So currently we do it by section because we do have access to the sections, but there are sometimes, like even within sections, that it makes sense to break it up, right? Because they're actually talking about 2 things in one section.
So wait a minute now, this makes me think, when Google returns results and they return the segment of the document that specifically relates to your result, right?
Mm-hmm.
As the summary underneath. I can't remember what technology they're using for that. Do you know? Because they're basically doing that, right? They're
right, exactly. Yeah.
I can't remember how the fuck they're doing that. Was that their BERT stuff? I don't know.
Yeah, they do use BERT a lot nowadays. So that could be definitely the BERT thing.
Right, but what I'm wondering is how they're framing it, because they're not framing it as a dialogue segmentation, right? They're framing it as maybe a squad problem,
Could be, yeah. Although I would think that, if it's a squad problem, then they're really good because squad, is not that, well, squad style stuff is really not that, the results are not that impressive. So I think they're more like they're doing, what you do here with kind of, when you do dynamic snippets, right, in search, you basically search against blocks of text in the document, and you take the text that most closely match with, so if you do more like this, it most closely matches with the document. And then you would basically rearrange those, or you take the block that is closest to the question.
Yeah. Yeah, I mean, definitely. Well, that the guy who posted on Slack, they were doing it at inference time for the segmentation. So maybe it is scalable, but I was thinking it's probably a lot of windows to calculate to do something like that.
Well, I mean, regular text, lexical matching is actually quite good.
Yeah.
If you use it right, it can be quite powerful. And the other thing is, it's explainable, right? Because it's lexical, you can see it, right? So, yeah.
What's your take, Sujit? So I'm trying to read up on like vector-based search and the semantic search. It's kind of overwhelming. And what do you see? Like, is there any way, like, good way to getting started with this particular area?
Easiest thing is I mean, if you have a vector problem and a solution, I would say easiest. This is the way I started. I used NMSlib.
NMSlib, okay.
Yeah, NMSlib doesn't need GPU. In fact, it performs well on CPU. It performs better than FICE, right? But then once you get comfortable with NMSlib, you can try FICE. Again, all in memory, really. Well, slightly better, more richer API than NMSlib. NMSlib is like dead simple, right? I mean, you just load it up. I think it gives you only one method, but it just works, right? FICE gives you multiple methods, and there are variations. Pinecone has, Pinecone is basically a search web-based thing around FICE, so they use FICE a lot. They have a set of blog posts about FICE, which are like really, so FICE itself doesn't have too much documentation. But Pinecone, these blogs are like, almost like documentation. If you're interested in FICE, you should read them.
Dude, if you got $100 to spend from your company,
yeah,
Pinecone's a managed service. The easiest way to sort of proof of concept capability and understand the affordances of a vector-based search. What was the library, Sujit? MLSlib? What is it?
NMSlib.
Yeah.
NMSlib.
Yeah. Non-metric spaces, I think it's NMS. Yeah.
I know the FICE one for sure.
And sorry, go ahead.
No, go for it. Dude.
And what type of data sets do you use to play around with it? Like, because that is also one. Yeah, size-wise, just to get started.
Yeah, size-wise, NMSlib I've used about 10,000-ish, which is like really small, 10, 20,000. With FICE, I've actually skipped FICE altogether. I don't use FICE that much. Vespa came up. So Vespa I've used like, 500,000-ish data sets. Still small, but that's
no. What I meant to ask was, so for example, getting started, what is the toy data sets that you would actually like that you typically use? That you use to play around with these types of problems?
Yeah, I basically just extracted stuff from BERT, right? The vectors from BERT, and I use those as my thing.
Yeah, so for all the vector engines, you can basically the input of these engines are the vectors. So you basically whatever text you have, you could use the news groups, right? The old classic news.
Yeah.
And you could feed that into BERT or feed that into like get embeddings. You just get your things from wherever, like a sentence encoders, right? Sentence embeddings or whatever. Universal sentence encoders. And you just do that and shove that into the engine. And in the engine, you have to decide which indexing technique you use. I don't know how important that is in terms of the quality of the results, but yeah, right, Suji? So just any collection of documents, and then you got to get some embeddings from somewhere, and you just use your intuition.
Right. So in your case, maybe you could use your data set of tickets, all the text from there. So I use that. I actually didn't use any third-party outside data sets for text, because last job and in this job, I don't have problems with data. I have tons and tons of text here.
Right.
Yeah, so well, that's where it was. Oh, and back to the snorkel thing that I was telling you about. This was a binary classification problem. I was trying to figure out if abstract is AI/ML abstract versus not AI/ML abstract. And I had some test data to play around with. So I used that test data to train these different classifiers using different embeddings and using those as LFs, right? So the classifiers built on top of these embeddings. So essentially, I'm taking input, I'm taking the text, I'm sending it through these pre-trained language models, getting the embedding, using the embeddings to train my classifier. And again, it's a fairly small data set. So these are all not very powerful classifiers because of, not too much data. And then using the outputs of the classifiers as my labeling functions.
Okay.
Right? So that was my thing. Yeah.
Yeah, this is also someone actually mentioned, I think Niranta, someone's like using zero-shot classification as part of your labeling function as well.
Yeah.
Okay.
It's interesting with the Pinecone, they have use cases. And so there's deduplications one, believe it or not. And then they have the extreme classification, they call it. I can't remember the other ones, but they lay it out very clearly. Yep.
Yeah. Simon Hughes actually gave a talk. I watched like this recent Haystack. It was actually pretty good.
Okay.
Yeah.
You have a link. You have a link to it?
Yes, sir. I think it's. Let me see if I can find it.
Yeah, I think they released the talks. I didn't go this time, but I should have. I mean, a colleague just he pointed out it's like $25. I could have just gone.
What was it?
Haystack. It's a relevance search conference.
Yeah, this is. Let me just paste the title of the talk, and you might be able to easily get it. I'll just paste it in the Slack. Yeah.
Cool.
It's pretty good. I really like the talk.
All righty. Manny, why are you so interested in vector search stuff? What's your use case? Is it for the same stuff you've been talking about, or is there a different use case you're thinking?
No, this is a different use case. This is for search itself. I'm just trying to understand this this whole space is like, we have like normal like lexical Solr based search, right? So I'm trying to understand like the architecture system design for these vector search, just trying to understand this area, like see if, because this is quite new to me. So yeah.
It's basically opportunities, future opportunities.
Yeah, just looking for opportunities, because there are like not just like textual, when I say textual search, like not human-based search, but there are like, error patterns that we can actually extract and see if, I'm just looking for opportunities here, like what's all it try to, learn by doing. That's why I'm trying to ask people.
Have you looked, this is a little crazy, but Odinson, ODINSON, remember, CG, you brought that up last time. It's like real-time fact searching. So it's a little out there for you. In terms of finding things that you're looking for in your base of, here, I pasted a link to it. Or I think there's a GUI too, where you could try it out. But it's like fact, it's a syntax for fact-based searching.
Right. It's more like, I think the big use case, at least for me, would be to get targeted training sets out of the data sets, right? Because you can stuff a lot of other things in it, right? As you parse these text sentences, text blocks, or even at the sentence level, you can do part of speech, you can do entity tagging, and all of it is stored along with the sentence, right? So then you can search on it. You can say, okay, give me all diseases which are followed by, incidence of, right? The phrase incidence of, or it is all diseases followed by a verb, right? So it's quite powerful because you can abstract away search, it's like you're no longer looking for specific instances. You're looking for global.
No, I remember your main use case. It was, I'm writing grammars. Help me. It was like your brain on, it was a bionic grammar rule building tool.
Right. Yeah,
right?
Exactly. So you can get things at a more at the conceptual level. You can search sentences using this
Right. So Manny, if you were trying to pull out facts, like you just explained something that sounded kind of like fact kind of stuff, but if you're trying to look at all your tickets and try to pull out subject, predicate, object, or like some sort of patterns.
Yeah, the error patterns are really like tough because right now people use regular expressions and stuff like that to get the error patterns. So basically, like if this pattern matches, do something, or like give this resolution automatically.
That's a crude knowledge based approach, but of course we're also talking about all the types of
I have to drop, sorry.
Okay. All right, guys, we've been going long enough. Does anyone else have to talk about, or we'll just we'll continue next week? All right.
Cool. All right.
Thank you.
All right. Thanks, Manny. Enjoyed it. See you, Yuri.
Thank you. Bye.
Take it easy, guys. Bye. Bye.